Amazing. Thank you for finding time again today to accompany us to work out one question on complex numbers. I think it's complex numbers, but it's not complex per se. We're going to simplify that. Accompany us to our question today. First things first, thank you very much for your support. Thank you for the comments. Actually, this is one of the questions that we got from the comments. And we're going to handle it simply, not in a complex way. Thank you very much. Given that z cubed plus z plus 10 is equal to 0, that's an equation, we're supposed to verify that 1 plus 2j is a root of that equation, and we find the other two roots. Solution. What we need to do? Verify. So we have z cubed plus z plus 10 is equal to, where z is, we put 1 plus 2j, and that is cube. We add z, 1 plus 2j, close the bracket, we add 10. Substitution. Then we have, if you expand this, it's like 1 plus 2j multiplied by 1 plus 2j multiplied by 1 plus 2j. Simple. Then we have add 1 plus 2j, add 10. Open the brackets. This gives us 1 plus 2j. This one can be written as 1 plus 2j squared, because it is this times that. So we combine the second two brackets. We add 1 plus 2j, then we add 10. What do we do here? Open this bracket first. 1 plus 2j. This one gives us 1 plus this times that times 2. You get 4j. Then 2 plus 2j squared. What does it give us? First, it gives us 4 when you square 2. When you square j, you get negative. So that j goes. We remain with 1 plus 2j. We close the bracket and add 10. Combine these two, we have 1 plus 2j, open the bracket, negative 3 plus 4j, close the bracket. Then we have plus 1 plus 10 plus 2j. This one is a number and that is also a number. So we add them together and get 1 plus 2j into bracket minus 3 plus 4j, close the bracket, we add 11, we add 2j. I think that is fair, isn't it? Right? Now we have 1 into, we are opening this bracket by 1, negative 3 plus 4j. We open the same bracket now by positive 2j. So plus 2j into bracket, negative 3 plus 4j. Close the bracket. We add 11, we add 2j. Simplify that, get negative 3 plus 4j minus 6j. This times this gives us negative 8j squared. Actually, it's supposed to be just 8 because we have removed the j squared with that negative. Then we add 11, we add 2j. This and this, what does it give us? Negative 3, this and this is negative 2j. Bring this positive j there, we have 2j. Then we have negative 3 and negative 8. This is going to give us this plus that is negative, positive actually 3. Now this is negative 3, this is positive 3. What happens? They will need to cancel out. So cancel out this one and this one. This is negative, that is positive. So They cancel out. Cancel that. What do you remain with? This one is equal to 0. That was our left-hand side. It is 0. And our right-hand side is also 0. We have verified as required. Perfect. Now we do part B. We're supposed to find the other two roots. Here, we need some more information. Now, this complex number, we can call it ZA is equal to 1 plus 2J. We can write this number in another form. There are about 4 forms. So this is the first form. We can write it as Z is equal to R exponential J theta. We can also write this one as Z is equal to R into cosine of theta plus J, the sine of theta, where theta is called the argument and R is called the magnitude or the modulus or the size of that complex number. So our main aim is to find R and theta. So R is equal to the square root of A plus B squared. And this is equal to, from our complex number here, A is 1. We square it, we add. Our B is the coefficient of J, which is 2, so 2 squared. When you work this one out to get the square root of 5, we are not going to use a calculator there. We leave it the way it is. Now we get theta. Theta, which is the argument, is equal to the tangent inverse of B over A, which is equal to the tangent inverse of our B is 2 divided by 1. And this is equal to, now we need a calculator. Let me check from the calculator what we have. We have the tangent of 2 is 63.43. So this is 63.43. This is 63.43 degrees. We have the magnitude or the modulus. We have the argument, which is 63.43. Now we can express ZA is equal to 1 plus 2J in another form. That form is called polar form. Polar form, we write this one as the square root of 5, that is our R, into bracket the cosine of the argument. Argument is 63.43 degrees plus J, the sine of the argument. Argument is 63.43 degrees. We have written the same complex number but in a different form. So this can be called as the first root of that equation. Actually, it is this same number here. So we need to get 2 more roots of that kind. The other one, we can call it ZB. It is going to be the same magnitude but a different argument. Same magnitude, different argument. Now, because there are going to be 3 roots, there will be 3 roots separated by 360 degrees divided by n, where n is the power of z, the largest power. So we have 360 divided by 3, which is equal to 120 degrees. There will be 3 complex roots separated by 120 degrees. The first one is at 63.43. The next one will be the same size at a separation of 120 degrees from the first. So the second one is going to be the same magnitude but cosine of 63.43 degrees add 120 degrees plus J, the sine of 63.43 degrees add 120 degrees. When we close, after adding 63.43 with 120, what do we get? So this gives us the square root of 5 into the cosine of 1 163.43 degrees plus j, the sine of 163.43 degrees. The third and the last root is going to be the same magnitude but 120 degrees from the second. So this gives us the ZC. ZC is equal to the square root of 5 into the cosine of 163.43 degrees plus 120 degrees. We add j, the sine of 163.43 plus 120 degrees. Then we close that bracket, we close the main bracket. When you add that, you get the square root of 5 into the cosine of 163.43 plus 120 is 283.43 degrees. We add j, the sine of 163 plus 120 is 283.43 degrees. We close that bracket. So these are the other two roots, ZB and ZC. That is how we solve that question. And if it looks like it's complex, because it's a complex number, please send us more questions and we will address the gray areas if there are any. And thank you very much for watching. Keep supporting the channel. We are growing together. We started together. And make the subscriptions. Share this information with your friends, your family, your relatives, and let this message again spread to all those people who find it complex. We will simplify it. Thank you very much, and do this again in the next lesson. Keep subscriptions coming. Keep watching. Keep learning. Keep growing with us. Thank you very much for your support. See you next time.